Okay, so zeros of a polynomial function. What are zeros of a function? What is it?
A zero.
A zero, yeah. Way to use the word. Zeros of a polynomial function are a solution, also known as an x-intercept. Okay, so those would be zeros. So if I had f of x equals x times the quantity x minus 4 times the quantity x plus 3. What are the zeros of that function? How do I find them? Set everything equal to 0. So 0 here, and here, and here. Yes? So we have x equals 0. And what would I get from this quantity? X equals 4. And from this one? Negative 3. Now, I personally would put these in this order when I did it. Negative 3, 0, 4. Can anyone guess why I would put negative 3, 0, 4?
Least to greatest.
Least to greatest. Because if I were to graph this,
It's going from left.
it goes from left to right, and I can just graph them straight across. So, negative 3, 0, and 4. So if I were to multiply all this out, what degree of a polynomial would I have? Well, this quantity times this quantity would give me x squared, correct?
Mm-hmm.
But then I multiply it by another x, it would be what?
X cubed.
X cubed. It's going to be x cubed, and is it going to be a positive x cubed or a negative x cubed? Positive. So odd functions start and stop at the opposite direction, yes? So this is positive, so it's ending up, so it's starting where? Down. So we know that over here the graph is going to go down, and over here the graph is going to go up. So the whole point of what we're doing is to graph things. Okay? So I need to know whether this graph over here is positive or negative. Everything above the axis would be, x-axis would be what? Positive? Because is this the positive y-axis? Everything below, actually I'll just put it over here. Everything below would be what? Negative. So I have an interval from negative infinity, because that's over here, right? Negative infinity to where?
Negative 3.
Negative 3. So my interval is negative, I feel like I'm really close. Negative infinity to negative 3. And then I leave negative 3 and stop where?
4.
No,
Oh, 0.
0. So negative 3 to 0. Because if I have a 0, it's like an open door. I have to go through it, yes?
Mm-hmm.
Okay. And if I have an odd multiplicity, I have to go through it. What if I have like an even multiplicity? Remember me bouncing off the door? Have I done that for you guys yet?
No.
Oh, I get to do that today. Okay. And then I leave 0 and go to what?
4.
4. So I go 0 to 4.
And then
Oops.
4 to positive infinity.
And then 4 to positive infinity. So what we do is, this is called interval analysis, because these are intervals. I've given you 4 intervals, correct? If you think about the x-axis as a big piece of string, and I cut it 3 times for my zeros. So if I cut a piece of string 3 times, how many pieces do I have? 4. So I have the n, middle, end. Okay? So I just pick a number. Pick a number anywhere between negative infinity and negative 3.
Negative 72.
Okay. So then we're going to write negative 72. It's a little obnoxious. So we're going to put negative 72 in for all these x's.
Oh, damn.
Well, we're not going to do the math. We're just going to. If I put negative 72 in for this x, it's going to be a negative. Yes?
Mm-hmm.
And if I put negative 72 minus 4, is it still going to be a negative?
Yeah.
Yes? And if I put negative 72 plus 3, is it going to be a negative or a positive?
Negative.
Negative. So if I have three negatives times each other, it's going to be a what?
Negative.
Negative. Did that what we say it was going to be? If it's going down, is that what it has to be? Yeah. So over in here, I just put a little negative. So I know that I'm down here. So now we need a point between -3 and 0.
-1.
-1. You notice how I'm writing -1, so you and I both know what I picked. So I'm going to put -1 in for this x, and I'm going to get a
Negative.
negative. I'm going to put it in the next quantity. Am I going to get a positive or a negative? Brandon? If I put -1 into the next quantity, do I get a positive or a negative?
Negative.
Okay. Austin, when I put it into the last quantity, do I get a positive or a negative?
A positive.
I get a positive. So I have a negative times a negative times a positive. So what do I get when I'm done, Cooper?
Positive.
Positive. So this piece of the graph right here is what? Positive. Is ever shaking? Can you please stop? It shakes the whole floor. So now I need between 0 and 4. 3. Everyone okay with 3?
Mhm.
Okay. So Olive, what do I get?
Positive.
A positive. Sam, what do I get in the next one?
Negative.
Negative. Emma?
Positive.
Positive. So I have positive, negative, positive. So what do I get?
Negative.
A negative. So again, it's following its pattern, right? That it should be.
Mhm.
Cole, give me a number between 4 and infinity.
3?
Between 4 and
Oh.
infinity.
5.
5? No, 3? That's not right. You could pick an infinite amount of other numbers, not 3. Okay, so Cooper, positive or negative?
Positive.
Are you just guessing?
Yeah.
Okay,
Good
Cooper,
shot.
if I put 5 into an x, isn't it positive?
Yeah.
Yeah. I put that 5 for that x, it'd be positive, right? Okay, Cooper, if I put a 5 in here, is it going to be positive or negative? 5 minus 4, positive or negative?
Positive.
Okay. Put it in this one.
Positive.
Okay. Now do you get it?
Yeah.
Okay. So positive, positive, positive. So the whole thing is going to be what?
Negative.
Olive, not helpful. Positive. Okay. So is that what we said was going to happen? Yes? So we're going to start down here, go up. We don't know how much. That's for pre-calc and calculus to figure out. Come down and go back up.
Are we supposed to draw that?
Yeah. Now, we don't know how high it goes or how far down it goes, do we?
No.
No, but that's not what we were going for. We were going for the zeros. So a 0, when it's just 1, just happens once. -3 just happened once, right? 0 just happened how many times? Once. And 4 just happened once. If a 0 happens an odd number of times, and the reason I say odd number, if I had x cubed equals 0, how many times would x equal 0?
3 times.
3 times. Okay? So this would be a multiplicity of 3, because it would happen 3 times. If I had x minus 4 to the 6th, how many times is x going to equal 4? 6 times. So it's going to have a multiplicity of 6. So anytime it is odd, it's like an open door.
Quizzball meeting during junior high IAP today. Please check in with your IAP
In the
first
basket.
and then go to the
And
meeting.
don't touch
If
it.
anybody is just curious as to what it's about, or you want to be in it, please.
Okay, and if I have a
play
multiplicity
during IAP today.
of an even, it's a closed door. And I'm going to show you what I mean by that.
Oh yeah, run through the door.
See, remember? I showed you guys this.
No, you didn't.
If I touch the door one time, what happens?
You touched it one time.
What happened to the door?
It opened.
It opened. Can I walk through it?
Yeah.
Yes. I touched it again. What happened?
It closed.
It closed. So when I try to walk through it, what's going to happen?
You can't.
You can't. You just run into it.
I'm running into it, but what's happening?
Nothing. You're stopping.
Am I staying at the door?
No, you're bouncing out.
I'm bouncing off. What do you think a graph does?
Bounces off.
Bounces off. I touch it a third time. What happens to the door?
It opens.
I can open and I can go what? Through it.
Why does
I
it
can
do
go
it
from
4
positive
times?
to negative or negative to what? Positive. But if I touch it again, what happens? It closes. That's 4 times. So I'm going to do what?
Bump off of it.
I'm going to bounce off of it. So anytime you have an odd multiplicity, what is the odd number that we have most often for multiplicity?
1.
1. You go through it. It's a door. It's an open door. But if it has an even multiplicity, it is a closed door and the graph is going to do what? Bounce off of it. So when you have your assignment, they'll say state the multiplicity of the zeros. If it's a multiplicity of 1, I don't want you to state that. Okay? And typically how I do that, so if I have x plus 5 to the 7th. Well, this would be x equal to negative 5, yes? How many times? How many times would it equal negative 5?
7.
7, because of right here, yes? So I just go times 7 really small. Just to, instead of writing multiplicity of 7, and sometimes they'll just write M-U-L-T. So if I have x minus 10 to the 10th, x would equal what?
10.
10. How many times? 10. So you just put times 10. So what would happen here at negative 5, I would go through my 0, yes?
Yes.
And what would happen at 10?
No.
What would happen at 10?
It goes through the
I would hit it and go
bound.
back down, or if I came this way, I would go back up. I shouldn't do that on 1 because it looks like the same thing, right? So when it's an even, it's going to bounce. Okay. And they call it a turning point, but it bounces. An odd multiplicity, it what? What does the graph do? Goes through. Make sense? Tell me when I'm good to change it. Everyone good?
Yep.
Okay, so if I gave you a graph like this, what are the zeros and what's the multiplicity?
Um,
2 and
0.
where does it cross the x-axis?
2.
2 and negative 2. Okay, it crosses as positive and negative 2, doesn't it? What's the multiplicity? Do you know?
No.
But it goes through it, so you know it's odd, correct? I know that x equals plus or minus 2, but do I know the multiplicity?
No.
No, but do I know it's odd?
Yes.
How do you know it's odd?
Because it goes through.
Because it goes through. Okay?
That's an even multiplicity.
Well, this one has an odd,
That one's odd, but that one's even.
and the other one is
Even.
even. Why is it even?
Because it bounces off.
Because it bounces off. See how that makes sense? So I could say, well, since this is 2 and this is 1, Could it be a degree of 3? It could be, right? Could it be a degree of 6?
No,
Why not?
because that's even.
Because that's even, and this graph starts down and ends up, and that tells you it's a what function?
Negative?
Not
Or
negative.
odd?
Odd function, doesn't it?
Mm-hmm.
So you will have some in your assignments that say, what could the degree be? What could the multiplicity be? Because this multiplicity could be 10, couldn't it?
Mm-hmm.
Or 20 or 30. But could it be 7?
No.
No. Am I getting through what I'm saying?
Yeah.
Okay. Do I need to keep doing it?
No.
Okay. Okay. This is where I wish I had my PowerPoint because my pictures would be nice and pretty, but my picture isn't going to be nice and pretty. Just have to get over it.
Try.
Okay. Okay, so this equation, I should have, there, that's better. This equation right here is f of x equals x cubed plus x squared minus 3x minus 6. Okay? That's that equation. I want you to find all the zeros. Well, if I know 1 0, I could factor, yes. Could I factor?
Yeah.
By grouping, because there's 4, if it works. Would factoring by grouping work on this?
No.
Because you have a 3 and a 2 here, and you can't make that look like 1, can you? No. Okay, so factoring by grouping isn't going to work. But you have a picture. And if I know 1 0, can I do synthetic division to make my thing? Or I could also do long division. You want to do long division?
No.
No. You want to do synthetic? Okay, so what's one of the zeros? X equals what? 2. So I can synthetically divide this, right? So how do I do that? How do I do synthetic division?
Oh,
So
you would
it'd
do
be
6
negative
or
two, right?
2, -2.
No, not -2, because x equals 2. If it was
Positive
x minus 2,
Oh, yeah, okay.
right?
So then, just regular 2, and then you do your little box thingy. And then, 1 plus, and then just a 1, and then a -3, and then a -6.
Okay, where did you get those numbers from?
Because x is 1 cubed, and then x squared is just 1.
Okay, so I put my coefficients.
Yeah.
Okay, now do you know why I made you do yesterday's assignment?
Mm-hmm.
Okay, so I bring down a 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -3 and 6 is 3. And 2 times 3 is 6, and it came out to be 0. Well, it should have come out to be 0 because if it is a 0 of a function, the remainder is what?
Yeah.
0. Just like if it's a factor of a function, factor of a number, you don't have. So this started x cubed, so it's ending x what?
Square.
Squared plus 3x plus 3. Well, I have a quadratic, yes?
Yeah.
So I should be able to factor or use the quadratic formula. Do you know why we did Monday?
For this.
Okay, so 1 times 3 is 3. Factors of 3 that add to 3. There aren't it. Because the factors of 3 are 1 and 4. 1 and 3, right? So you can get 4 or you can get 2 by subtraction, but you cannot get 3 by addition, can you? Okay, so we can't factor it, so we have to use what? quadratic formula. So x equals
Negative
-3
3.
plus or minus.
Square root of 3 squared.
So 3 squared, which is 9, minus 4 times 3 times 1. So that's -12. All over 2
6.
times a.
Negative 6.
2
Or-
times
2
a.
times A. So 2.
Remember, x equals negative
I know, I was
b
looking at
plus or minus the square
I
root
accidentally did B.
b squared.
Minus 4AC. Oh, wait, 2A. That stupid song is always in my head, Miss Mick.
Good. 4ac.
I'm gonna be like on my deathbed singing that.
Good. Okay, now, when we look at this graph, there's only one real zero, isn't there? Okay, but since it's a trinomial, it's a degree of 3, there has to be 3 zeros. But do they have to be 3 real zeros? No. So we're going to have imaginary numbers because 9 minus 12 is what?
Negative 3.
Is -3. So we have the square root of -3. So x equals -3 plus or minus, well, the square root of 3 doesn't simplify, does it? No. So I square root of 3 all over 2. And the real zero we had was what? 2. So it didn't say find all the real zeros. It said find all the zeros. So these are all zeros. What are the real zeros? Real has 2 L's in it now. I was going to write really zeros. What are the real zeros? X equals what?
X equals
Here are your 2 zeros. Which ones are real?
2.
2. Because I is a complex number, isn't it? So do you see how everything we've done for the last 2 months just went into one thing? So I think we need to do this again. What do you think? Okay. So the equation for this, well, what degree is this one? What do you think?
Odd. No.
Has to be even, Rye. Why does it have to be even?
Oh, they both go up.
They both go up or they both go down, so they have to be even. So, and it looks like there's 1, 2, 3, 4 pieces, so it's a 4th degree. Okay, so f of x equals x to the 4th minus 3x squared minus 4. From the picture, what zeros can you get? What zeros are there?
2 and negative
2 and -2? So we're going to do the same thing we did before. We're going to use synthetic division to help me. You want to divide by 2 or -2 first, Cooper? You want to divide by 2 or -2 first?
Doesn't matter.
No?
-2.
Okay. So -2. What do I have to remember to fill in here?
X cubed
X cubed.
and
And what do I fill in x cubed with?
0.
A 0. And then
Negative 3 and then 0 again.
a 0 again. Why a 0 again?
Because
There's missing an x, right? And then -4. Since we know from the picture that -2 and 2 are zeros, what better our remainder be?
0.
0. So you do it and I'll do it. You better get a remainder of 0, right? Did you get a remainder of 0?
Yeah.
Did you get 1, -2, 1, -2?
Mhm.
Yes. Okay, so we started off with the 4th degree. So this is the 3rd degree, correct? Now we could factor it maybe by grouping, but do we also know that 2 goes into it?
Mhm.
So we can do what is called repeated synthetic division. So we're going to take our answer and divide it again. If you divide 8 by 2, don't you have to divide it by 2 again?
Mhm.
Same thing. So now we had -2, we're going to divide by what?
Positive 2.
+2. So you do it and I'll do it. See who finishes first. Done. Did you get 0 for remainder?
Yeah.
Okay. So we started off with the 4th. The answer, the quotient, was cubed. The second quotient will be what? Squared.
Squared.
So I now have x squared plus 1.
Yeah. Would it be X?
No,
No.
because this would be x squared plus 0x plus 1.
Yeah.
Okay? So don't I just set this equal to 0 then?
Yeah.
And then I would do what to solve it?
It would be X squared equals -1.
So x squared equals -1.
Yeah, and then you have to square them both.
Square root
Yeah, that.
them both. So x equals plus or minus, correct?
Mhm.
And what is the square root of -1 equal?
9.
I. So all zeros, what's another name for zeros? I gave them to you. X-intercepts.
Oh yeah.
What's another one? Solutions. Okay. Now, I am going to take out one of these because it doesn't fit after we write it. I'll just explain to you. So we have x equals plus or minus 2, correct?
Mhm.
And plus or minus I.
Mhm.
Now, I will accept zeros on here, and I will accept solutions, but I won't accept x-intercepts. Why? What is an x-intercept?
When it crosses through.
Where it crosses the x-axis. So when we have unreal solutions, can we interchange the x-intercept name on there?
No.
No. But when we have the real zeros, can I now put x-intercepts?
Mhm.
And also solutions? And what are the real? X equals what?
2.
2. Oh, plus or minus 2. Don't forget plus minus. You got 12 through 17, right?
Yeah.
Make sure I get everything covered you need. Okay, so one more, and then I'll let you go. I want to solve the polynomial equation. I have 2x cubed plus 5x squared minus 3 equals, 3x, sorry, equals 3x cubed plus 8x squared plus 1. I didn't have it up there, sorry. So what's the first thing I need to do?
Combine the two.
Set it equal to
0.
0. And I know what you meant, but we're on opposite sides of the equation, right? So do you want to go to the left or you want to go to the right?
Yeah.
All right. This is right. This is left.
Yeah.
I want to go to the right. Why do I want to go to the right?
Because you won't end up with negatives.
I won't end up with a negative leading coefficient, right? Do you see that, Emma?
Yeah.
Okay, you can do it the other way, but then you have to factor out a negative. That's more things we'll get wrong, right? So I'm going to move every single thing over here. So I'm going to minus 2x cubed minus 5x squared and minus 3x. And you notice I moved the 3x to the outside. Why did I do that? Austin, do you know why I did that? Why I wrote the 3x over here?
Are you adding 3x?
Oh, yes. Do you know why? What'd I do with these?
Well, 3x doesn't have a...
There's no x over here, is there? So I threw it over here so I didn't put it on the 1.
Oh,
You see that?
yeah.
Okay, so I have x cubed plus 3x squared plus 3x plus 1. You guys agree with me? Okay, so it is a third degree, but we can factor by grouping, can't we? Sometimes. Isn't that we do when we do our binomial factoring? Okay. What happens if I group the first two? These two.
You have different coefficients. Or not coefficients.
No, what can I factor out?
X squared.
X squared. And what am I left with?
X plus 3.
X plus 3. Remember, always bring that sign down, right? And 3x plus 1, what do they have in common? 1. So 3x plus 1. Uh-oh. Did that work? No. Do we have to group the first two and the last two?
No.
No. Okay, so that grouping didn't work.
We should do 3x squared plus 3x and then...
So you want to group these two
Yeah.
and these two?
Yeah.
Okay. So this would be x cubed plus 1 plus 3x squared plus 3x.
Mm-hmm.
Okay. So what can come out of here? Nothing. What can come out of here?
An x. 3x.
3x. So I have 3x. Well, it would be a 1, right?
Mm-hmm.
It would be x cubed plus 1. So I had 3x, and I would have x plus 1. Did that work?
No. But
What do you
it
mean,
doesn't give
kind
the same
of?
thing. But it doesn't give you the same answer.
No. But I do know here, isn't that x equals negative 1?
Yeah.
Yeah. And remember we did the sum and difference of cubes a long time ago?
My quiz bowl meeting
And
is
that
over, so they
goes-
should be returning to their
The
IEP.
cube root of x cubed, what's that?
What?
X. Same sign. What's the cube root of 1? 1. Okay, so we have to, oh, when I look. Okay, so now what you square the first thing. What's x squared? X squared, right? Opposite sign, minus. Multiply these two things together.
X cubed.
No, 1 times x.
Oh, I thought you were playing it.
No. What's x? And you square the last thing. 1. So did I get x plus 1 on both of these things?
Yeah.
So I could factor this out, couldn't I?
Yeah.
Do you see that? Am I too low? We said nothing could be factored here, but can't it factor like this?
Yeah.
And don't we have this and this factor the same?
Yes.
So we know what is a 0 of it.
X minus 1.
X minus 1. So could we use that with synthetic division to find the rest?
Yeah.
Yeah. Okay, so let's come back up here to this x cubed plus 3x squared plus 3x plus 1. And synthetically divide by what number? What one do we know? Negative 1. So I get 1, 3, 3, 1.
Mm-hmm.
So 1, negative 1, 2, negative 2, 1, negative 1. And we knew it had to come out to be 0, right? Well, if we were right. So now I was x cubed, I'm x what? Squared plus 2x plus 1. Well, can I get the factors of 1 to add to 2?
Yeah, 1 and 1.
So it would be x plus 1 what? Squared? Wouldn't it?
Oh.
So if I have x plus 1 time over here, and I have x plus 1 time over here, I have x plus 1 to what power?
3.
3.
And that's the answer?
So all of the real ones are x equals
-1.
-1. Now, do I go through or bounce off? As a multiplicity of what?
Go through.
As a multiplicity of 3, so it goes through. So -1. So something over here happens. And it comes. And it has to do something over here, and then what?
And then go back down?
It has to go back up, doesn't it?
Oh, yeah.
Because it's a cube. But do we know this? No.
Or no.
No, we don't know that, do we? Okay, so you guys have, what do you have, 12 through 17?
Mm-hmm.
So we're going to be doing a lot of investigating when you're doing it.